This question asks you to use polynomial functions to model some situations in probability. Two unbiased four-sided dice with faces labeled 1, 2, 3, and 4 are thrown and the scores recorded. The random variable m denotes the maximum of these two scores. The probability distribution of m is given in the following table, this table. Question A, find the expected value of m. A formula is given in a data booklet. It says that it's the sum for all possible values of m multiplied by the corresponding probability. So it's 1 times 1 over 16 plus 2 times 3 over 16 plus 3 times 5 over 16 plus 4 times 7 over 16. It is equal to 1 plus 6 plus 15 plus 28. It's 50 over 16, which is 25 over 8. An alternative way to represent the probability distribution of m is to use a polynomial function g, where g of t is equal to this. Hence, for the distribution of m, g of t is equal to this. To be more clear how it works, you can see that it's the sum for all possible values of m, probability multiplied by t to the power of m. So it's 1 over 16 times t to the power of 1 plus 3 over 16 times t to the power of 2 plus 5 over 16 times t to the power of 3 plus 7 over 16 times t to the power of 4. Question B, find the g of 1. So we can substitute 1 for t into g. To find the required value, it becomes 1 over 16 plus 3 over 16 plus 5 over 16 plus 7 over 16, which is 16 over 16, which is 1. Or you can notice that when t is 1, it's just the sum of probabilities of all possible outcomes. It's the total probability, it's 1, and it will be true for any distribution. The next, find derivative of g of t. You can see that it's a function of t and we need only x to the power of 1 derivative. It's n times x to n minus 1. So t derivative is just 1, so it's 1 over 16 plus t squared derivative, it's 2 times t, so it's 6 over 16. You may simplify it, plus 15 over 16 t squared plus 28 over 16 t cubed. Hence, shows that derivative of g of 1 is equal to the expected value of m. Substituting 1 for t into derivative of g, we get that it is equal to 1 over 16 plus 6 over 16 plus 15 over 16 plus 28 over 16, and you can see that it's absolutely the same. It's 50 over 16 or 25 over 8, and it is equal to the value of the expected value of m as required. The next, a bag contains 2 red balls and 3 yellow balls. 2 red, 3 yellow. 2 balls are selected. 2 balls are selected at random without replacement from the bag. Without replacement. The random variable x denotes the total number of red balls selected. The probability distribution of x can be represented by the polynomial function gx, where gx of t is equal to this. Question D shows that gx of t is equal to this, making it clear how the coefficients of gx of t have been determined. Let's make probability distribution table. So x, it's a random variable number of red balls taken, probability, and possible values of x are 0, 1, or 2, because it's without replacement, and 2 red balls, so the maximum possible value of red is 2. And you remember that one probability can be found as one total probability minus the sum of all other probabilities. So 0 red taken, it means yellow and yellow, and the first yellow is 3/5 times, because it's and 4 in total, and 2 yellow remains, so it's 2/4, so it's 3/10. Definitely it's more easier to find red and red, and then this can be found as 1 minus this minus this. But let's find this directly. 1 red, it means that it may be yellow red, but it may be red yellow. Yellow red, it's what, 3/5 times 2/4, plus it will be absolutely the same, so just times 2, so it's what, 3/5. And red, it's 2/5 times 1/4, which is what, 1/10. Let's check. 3/10 plus 6/10 plus 1/10, it's 10/10, it's 1, as it should be, because it's the total probability, it must be 1. So gx of t is equal to 3/10 times t to the power of 0 plus 3/5 times t to the power of 1 plus 1/10 times t squared, which is equal to 3/10 plus 3/5 t plus 1/10 t squared as required. The next. An unbiased coin and a biased coin are tossed. The probability of obtaining a tail on the biased coin is p. So one is unbiased, so probability to get the tail or head is a half, and the second is biased, and probability to get tail is p. The random variable y denotes the total number of tails obtained from tossing both coins. And again, to be more clear, let's make a table for y, where y is number of tails, and it may be 0, 1 and 2. And so the random variable y denotes the total number of tails obtained from tossing both coins. The probability distribution of y can be represented by the polynomial function gy, where gy of t is equal to this. Question E, given that the coefficient of t squared in gy of t is 1/3, find the value of p and an expression for gy of t. So when y is 0, it means 0 tails, it means head and head, and when y is 0, it's 1 tail, so it may be tail and head, or head and tail, or it can be found as or actually any probability also can be found as 1 minus the sum of all other probabilities, and 2 y is 2, it means 2 tails, and this coefficient of t squared arises when we consider this probability, and gy of t, it will be what? This probability times t to the power of 0 plus this probability times t to the power 1 plus this probability times t squared, and it is given that this probability is 1/3. So tail. The first is unbiased coin. So to get tail, the probability is a half, and to get tail for the second coin, which is biased, it's P. It's N, so it's product, and it is given that it's 1/3. Hence, P is 2/3. So probability to get tail and tail, it's a half times 2/3, it's 1/3. Probability to get head and head, for the first it's unbiased, so it's a half times head. For the second it's 1/3, so it's 1/6. Tail and head, so it's a half times 1/3 plus a half times 2/3. For the second it's unbiased, probability to get tail, it's a half, and for the second probability to get head, it's 1 minus P, because P it's probability to get tail, plus half times 2/3, and it's what? 1 plus 2, it's 3/6, or a half. So it's a half. Let's check. 1/6 plus a half plus 1/3. Its common denominator is 6, so it's a 1 plus 3 plus 2, it's 1, so it's correct. I remember so the required gy of t is equal to 1/6 times t to the power of 0 plus a half times t to the power of 1 plus 1/3 times t squared, which is equal to 1/6 plus a half t plus 1/3 t squared. The next, the random variable z denotes the sum of the total number of red balls selected x and the total number of tails obtained from tossing both coins y. The probability distribution of z can be represented by the function gz of t, where gz of t is equal to the product of gx and gy. Gx it's from the previous, it's this, and gy is this. Gx it's from this part. Question F. For random variable z, it can be shown that derivative of gz of 1 is equal to the expected value of z. Use this result to find the expected value of z. So we need just consider derivative of gz, which is equal to this product, and we need just find the derivative of gz of 1. So let's consider gz derivative of t. Since it's a product, we should use product rule, so it becomes gx derivative of t times just gy plus gx times derivative of gy and we need of1, so derivative of gz of 1 becomes gx derivative of 1 times gy of 1 plus gx of 1 times gx y derivative of 1. Gx, gy are given. Gx is this, gy is this. You can substitute 1 for t to calculate gy of 1 and gx of 1, but you remember this result that for any, it will be true for any distribution that g of 1 is 1. So we can say that it's 1 and it's also 1. Gy of 1 is 1 and gx of 1 is also 1. Hence, let's find, or let's write directly that it becomes, or let's show it clear. Let's write derivative in terms of t firstly. So gx derivative of t is equal to what? So let's find, so it's just 3 over 5 plus 2 over 10 t, or 1 over 5 t, and gy derivative of t is equal to a half plus 2 over 3t. Hence, g z derivative of 1 is equal to substituting 1 for t for derivative of gx, we get that it becomes 3 over 5 plus 1 over 5 times 1 plus 1 times half plus 2/3, and it is equal to what, 4 over 5, and it's what, 6, so it's what, 3 plus 4, it's 7 over 6. Let it be the exact, so it's 59 over 30. So it is equal to the expected value of z. Or let's write like this. Hence, the expected value of z is equal to 59 over 30. And that's all for this question.